welcome you all the lecture series of Principles of Compiler Design. In the previous video, we have seen the phases of compiler and each phases input and output, and first two phases in detail. In today's video, we are going to see the remaining phases in detail. So I recap that. So what are all the phases of compiler means? We have a lexical analyzer phase, that is next is a syntax analyzer, semantic analyzer, and intermediate code generation and code optimization and code generation. So these are all the 6 phases. For all the 6 phases, we have the common symbol table and error handler. So what is an output of the syntax analyzer? The syntax analyzer output is a parse tree. Next is the semantic analyzer phase. The semantic analyzer phase, it takes the input from as a syntax tree and get the information in the symbol table. It verifies that statement in terms of type declarations and type matching all the terms. So the important part of semantic analyzer is a type checking, and also if there is any mismatch in the types means it convert that type. For example, in our program we are using we do the computation like C is equal to A plus B means, suppose A comma B is declared in integer and C is declared in real means, that semantic analyzer check that type and convert it into the real. So that is the syntactically verified parse tree is generated, the output of the semantic analyzer. Next is the intermediate code generation. So the intermediate code generation input is the syntax tree and produces output as a 3 address code. So why we need that intermediate code means directly we convert high level language into the assembly level language. We are in between we have the 3 address, and from the 3 address we are convert means it will be very easy for the conversion of assembly code. So in the 3 address form of statement, the 3 intermediate in the different forms. One is the postfix notations and syntax tree, and that next is that 3 address code. So 3 address code means at most 4 operands, 3 operands should be there in that statements. Using the temporary variable we save the computation, and finally we do the whole computation in the same statement. For example, we have that statement like new value is equal to old value plus fact star 1 means, so that statement is converted as a token like id1 that is equal to id2 plus id3 star 1. So how that 3 address code is generated means, first that in the temporary registers we are store the value of value 1, numerical value of 1. Next is in the temporary register 2 we are multiply that id3 value into 1. Next we are converting, we are again adding that id2 plus the value in the temp2, and finally the whole computation value in the temp3 that could be stored in the id1. So the registers and temporary the temporary variables, temporary registers are used for the computations in the 3 address code. Next is the code optimizer. The compiler looks the large segments of the code to decide how to improve the performance. So the code optimizer means, so that could produce the optimized code. Optimized code means, suppose in our code any redundant statement or repeated statement or cost effective statement means, that could be optimized by the code optimizer. So what is the purpose of code optimizer means, it will produces that efficient code to improve the performance of the compiler. For example, in the previous 3 address code, if the it contains the 4 set of statements, so that could be reduced into the 2 state. So the redundant computations are reduced in the code optimizer. Next is the code generator. In the code generator phase, the optimized 3 address code is converted into the assembly level code. So what is the assembly code means? We have the mnemonics codes like move, multiply, add, and these are all the mnemonics are used. So the registers are used to store the variable values and identifiers values. So through the registers we do the computation. For example, we have the statement like id1 is equal to id2, id3, and star 1. Here we have the id identifier 2 and 3 values are stored in the registers like r1 and r2. So first we move r1 id3 value in r1 and multiply that id3 value with 1, and next we move the id2 value in r2, and next step we add that r1 with r2, and finally we assign that statement, the whole statement that could be in that r1, whole computation are now it is in the r1, that could be stored in the id1. So that could be moved into the id1 registers. This is the code generation phase using that assembly code that our high level language is converted into the assembly code. So this is an example of how that for example we have that x is equal to a plus b star means here we are trace that the input from all the 6 phases, and finally it produces the assembly code. That could be we'll seen in the next class. In today's video we hope that we'll understand what is a semantic analyzer, and what is the functionality of intermediate code generation, and why we need the optimized code, and how that code generation, that is an assembly code, is generated from our 3 address code. Thank you.